Okay, so we've been talking about perpendicular bisectors. Now we're going to switch modes and talk about angle bisector. Alright, so if a point is on the bisector of an angle, then the point is equal distance from the sides of the angle. This is called the angle bisector theorem. And this is the same thing. You remember how I said it's like a movie with a slow beginning and then the ending's really good? Well, that was the same thing. For perpendicular bisectors, that was a slow beginning. Who really cares about perpendicular bisectors and being equal distance to the endpoints of the segment? Who really cares? Well, when we put it on a triangle, really cool things are going to happen. So like right now, who really cares that this is an angle bisector? Oops. If I can even highlight it. Alright, it's an angle bisector. That part's congruent to that part. Well, then D is equal distance to both sides. Who really cares? Well, just for one angle, not really important, but when you put it in a triangle, really cool things are going to happen. And the converse of this theorem is also true. So, is there enough information to determine if AB is the angle bisector of angle CAD? The answer is yes. Why? Alright, that's the angle bisector of CAD. Alright, so this is the converse of the theorem we just talked about. We have point B and is equal distance to the sides. All these points are, all 3 points are collinear. So, boom, boom. Alright, yes, angle bisector converse. And in the grand scheme of things, for one angle, not that cool, but we're just practicing the basic skills. And then that way we can put it for a triangle. Alright? Is point Y on the angle bisector? The answer is yes. Alright? I can guarantee you that this angle bisector would go through point Y. Why? It's equal distance to the sides. So again, yes, angle bisector theorem. Alright, and then we're just going to do an algebra problem. Find the value of x that would force AB to be the angle bisector of angle CAD. So really, when you do these types of problems, it's just set them equal to each other. When in doubt, just set stuff equal to each other. So we're going to set this up right here, very fancy looking. Distribute x plus 7 equals 6x minus 8. Subtract x from both sides. We're going to get 7 equals 5x minus 8. Add 8 to both sides. We're going to get 15 equals 5x. Divide both sides by 5. We're going to get 3 equals x. Alright, so this was a little bit of a warm-up. In the next video, we're going to go to the iBook, page 42, and do another GeoGebra thing and see some pretty freaking cool things happen, alright? This is going to be a good punchline.